Hello everyone, a very good morning to all of you. So today let's talk about periodontal pocket. Okay. So in the previous video, I talked about the basics of inflammation. Kindly go and watch the video because I'll not take in depth about the inflammation now. I'll just tell you the pathogenesis of pocket, the basics of pocket formation. Because you know the basics, it'll be very easy for you to integrate the pathogenesis of pocket. Okay. I'll just give you a quick brief recap of whatever is taught in the last video. Whenever a bacteria enters the body, the bacteria will have a specific pattern surrounding it. That is what we are going to call it as pathogen associated molecular pattern. So this pathogen associated molecular pattern, which will be present in the as a covering for each bacteria, will be identified by the cells in our body, the receptors in our body. That receptor is called as pattern recognition receptor, which is nothing but toll like receptors, especially 2 and 4. I've talked everything in the previous video. Okay, I'm just quickly recapping it. Okay, so PAMP is recognized by the pattern recognition receptors. So once this is done, nuclear factor kappa B is activated, which is going to result in pro-inflammatory cytokines. What are the pro-inflammatory cytokines? Interleukin 1, interleukin 6, tumor necrosis factor alpha, and a chemokine called interleukin 8. So all these is going to result in series of events: transient vasoconstriction, which is followed by persistent vasodilation, increased vascular permeability, and there's going to be expression of certain selectins P, E, L, and ICAM in the walls of the endothelium. So this is going to give attachment to the leukocytes. So every leukocyte will have something called as integrins. These integrins, when they bind to the selectins, that is going to result in temporary attachment. When they bind to the ICAM, that is going to result in permanent attachment. So once they are permanently attached, they move to the site, chemotaxis, and then phagocytosis takes place. So once phagocytosed, the dendritic cells, they express these antigens via MHC1 and MHC2. Okay, and this is taken up by the T lymphocyte. That is going to result in activation of B lymphocyte, which is going to result in plasma cells and antibody form memory cells, which is going to result in activation of plasma cells and memory cells. Right, so this is what we have talked about in the last video. I have explained in depth why and how these steps are happening. So now once you are thorough with these basics of how the phagocytosis takes place and what happens in inflammation, okay, so now similarly you imagine a block or a calculus which is studded with bacteria. Say for example aggregative Bacterionomycetum comitans or P. gingivalis or any bacteria you take. So these bacteria, okay, they will stimulate the body to release the pro-inflammatory cytokines. Okay, that is what we are talking here. Imagine a bacteria will have, every bacteria will have certain weapons to fight against the human, right? See, say for example, if P. gingivalis comes, it is not going to tell, okay, you can kill me. No, it will fight against the body, right? So that is what we are going to call it as virulence factors. Every bacteria will exhibit certain virulence factors, be it collagenase, be it proteases, or any kind of enzymes that is going to destroy the body's connective tissue. Okay, so let's imagine P. gingivalis. Okay, so P. gingivalis, it enters and comes in contact with the epithelium. So the epithelium expresses toll-like receptors. It is going to induce a cascade of events resulting in a release of pro-inflammatory cytokines, all those stuffs. The P. gingivalis itself will have endotoxins as a weapon. It will have proteases. It will have collagenases. So imagine the name itself tells endotoxins. It is going to release some toxins that is going to destroy the body cells. Proteases destroy protein, collagen. Collagenases destroy collagen. So it will have some weapons that will be released by the bacteria or that will fight against the host defense. Now, although these pro-inflammatory cytokines which are released by the body to fight against the bacteria, it itself has some side effects. Okay, as I told in the previous video, it is going to result in increased expression of rank and rankle. Okay, so rankle will be present in osteoblast and rank will be present in osteoclast. Okay, so once this is expressed, that is going to result in bone resorption. Okay, so what happens in pocket formation is these pro-inflammatory cytokines, once they are released, they are going to result in destruction or movement of the neutrophils towards the bacteria. At the same time, the bacteria, what it does is, it will enter the epithelium, it will start destroying the connective tissue with the help of these enzymes, endotoxins, proteases, collagenases. Let us see how it destroys. Okay, that is what we call it as pocket pathogenesis. I'll tell you in a very, very simple way. Okay, so let us imagine this is a tooth. Okay, so excuse my drawing. Okay, now identify the parts. This is called as marginal gingiva. This is called as CJ. Okay, and you see a small space, right? So this space is called as the gingival sulcus. In the gingival sulcus only, we are going to enter the probe. We are going to measure the periodontal probing depth, PPD. Okay, now what is this structure? This is the junctional epithelium. So which is the first line of defense? Neutrophils. First line of barrier? Junctional epithelium. Okay, so what is this blue structure here? Gingival connective tissue fibers. It's not PDL, it's gingival connective tissue fibers. Dentoalveolar, dentoperiosteal, alveolo-dental, all those fibers. Okay, so it is gingival connective tissue fibers. And below the gingival connective tissue fibers, we have what is called as PDL. And this is the alveolar crest. Okay, so this is the basic structure of a tooth, how it will be built off. You have to get used to this view, otherwise you cannot blindly imagine. If I tell you it enters the junctional epithelium, it is going to destroy the connective tissue. No, you will never imagine. You just stick to this basics. This is how a structure of a tooth will look like. So sulcus, immediately below the sulcus or where the probe hits will be the junctional epithelium. Below the junctional epithelium you have gingival connective tissue fibers, and below the gingival connective tissue fibers we have a PDL. This is a basic structure. Okay, so now let us imagine patient is having a plaque. Okay, patient is having a plaque. Now, as I told you, plaque and calculus are nothing but bacteria, right? So I'll be talking about the stages of plaque formation, all those things later. Okay, so now just imagine plaque and calculus is basically made of bacteria, P. gingivalis. So as I told you, P. gingivalis, it releases some toxins, and you must have heard a common term called as whenever in pocket formation there is destruction of collagen fibers and apical migration of junctional epithelium. I am sure you must have heard these terms. There is apical migration of junctional epithelium. There is destruction of collagen fibers. Okay. Now you should ask me a basic question. First, as I told you, the first line of barrier is epithelium. Only when the epithelium gets destroyed, the bacteria can enter the connective tissue. So by the terms, I should tell that the epithelium is destroyed and the connective tissue is destroyed. But what I'm telling, there is migration of junctional epithelium and the connective tissues get destroyed. How? What is the junctional epithelium does there? So these junctional epithelium, they are semi-permeable membrane. Okay, so what it will do, once the bacteria enters, it will tell, okay, I'll be your friend, or you just attack my boss is inside. So what it will do, it will allow the bacteria to go inside, and what is present inside? The gingival connective tissue fibers. So once P. gingivalis comes, it will allow the P. gingivalis to move into the connective tissue. Why? Because it is semi-permeable. It allows the bacteria or other substances to pass in, as well as the GCF to move out. Okay, so the bacteria enters the junctional epithelium, it moves to the connective tissue, and inside the connective tissue, what it does, it releases what is called as MMPs. Okay, these bacteria, they trigger and release MMPs, matrix metalloproteinases. Okay, so the junctional epithelium is a semi-permeable membrane. So bacteria enters the connective tissue. So in the connective tissue, that is in the gingival connective tissue, it is going to release what is called as MMPs. Okay, so what are MMPs? MMPs, there are a lot of types. So predominantly we'll talk about type 1, which is collagenase. Okay, and there is something called as neutrophil collagenase. There is something called as gelatinase collagenase or gelatinases. So 8, 9. Okay, neutrophil collagenase, gelatinases. So all these basically, what is the function? Destroy the collagen. Okay, so what is the connective tissue is made up of? Be it gingival connective tissue or periodontal connective tissue, any connective tissue, it will have what is called as cells, fibers, and ground substances. Any connective tissue you take in the body, whatever it might be, it will have cells, it will have fibers, it will have ground substances. Cells, osteoblasts, osteoclasts, cementoblasts, fibroblasts, whatever it may be. And next one is fibers. Fibers, it can be predominantly type 1 and type 3 collagen fibers. We also have elastic fibers, all those things, but predominantly type 1, type 3 collagen fibers. And ground substances, proteoglycans and glycosaminoglycans. So this is the basic structure of a connective tissue. So when I tell you gingival connective tissue, it will have these three. Okay, when I tell you periodontal connective tissue, it will have all these three. So now what happens? The bacteria has entered, the bacteria has crossed the junctional epithelium, it has entered the connective tissue. Why? Because junctional epithelium is a semi-permeable membrane. Now what will the bacteria do? It will try to destroy all these, the cells, fibers, and the ground substances in the connective tissue. So it releases endotoxins, it releases collagenases, it releases gelatinases, all those things with the help of MMPs. So now what happens? The connective tissue structure is damaged, right? So what happens? The connective tissue is getting damaged by MMPs, by certain virulence factors of the bacteria. So once it is getting damaged, what is going to happen? It is destroyed. So what happened to the junctional epithelium is the junctional epithelium will be resting on the connective tissue. Since the connective tissue is getting destroyed, it will move down where the connective tissue is not damaged. So that is why I am telling you that there is apical migration of junctional epithelium during pocket formation. Okay, now again I'll tell you again and in another way. Okay, so imagine this is P. gingivalis. It crosses the junctional epithelium. It comes and sits in the gingival connective tissue. So in the gingival connective tissue, it causes the destruction of the gingival connective tissue fibers. So the gingival connective tissue fibers is going to get completely destroyed, right? So what happens to the junctional epithelium? What happens to the junctional epithelium? The junctional epithelium is completely dependent upon the underlying, so or it is resting over the gingival connective tissue fibers. Now because it is getting destroyed, what will happen? This junctional epithelium will move downward. Again, if PDL is getting destroyed, it will still move down. It will move to a point where the connective tissue is not destroyed. Okay, so that is why in pocket there is apical migration of junctional epithelium. And imagine, when there is apical migration of junctional epithelium, will my sulcus get increased? Will my sulcus depth get increased? Obviously. Why? Because the junctional epithelium is moving down, the sulcus depth will increase. That is what we call it as pocket. So pocket is pathological deepening of gingival sulcus. How there is deepening of gingival sulcus? There is destruction of connective tissue and there is migration of junctional epithelium apically. So because of the apical migration of junctional epithelium, the sulcus depth is going to get increased. So my probing depth is going to get increased. What is the normal probing depth? 2 to 3 mm. So this is the pathogenesis of a pocket. Okay, so the normally these pro-inflammatory cytokines, they trigger the release of MMPs. These bacteria, they release endotoxins, collagenases, proteinases. These two bundled together, they destroy the connective tissue fibers. Once the connective tissue fibers are destroyed, there's going to be apical migration of the junctional epithelium that results in pocket formation. Okay, so this is the basic pathogenesis of pocket formation. Okay, and I hope this video makes sense. So I'll be talking about what is PPD, what is CAL or CAL, whatever you call, in the next video. So clinical attachment level, clinical attachment loss, clinical attachment gain, periodontal probing depth or pocket probing depth, whatever you call in your college. Okay, so I'll be talking about that in the next video. So with this, the pathogenesis of periodontal pocket comes to an end, and the types of pocket I'll be taking in while taking about PPD. Okay, so I hope this video makes sense. Thank you so much. Have a nice day.